In 1977, two Boeing 747 aircraft collided on a runway in Tenerife. 583 people died. Investigation found something that nobody in aviation wanted to acknowledge publicly. The captain of the KLM aircraft, one of the most experienced pilots in the world, began his takeoff roll without clearance. His first officer knew something was wrong. The flight engineer raised a concern. Neither of them stopped him. Not because they lacked the information, not because they lacked the courage, because the cockpit culture of 1977 made it psychologically almost impossible for a junior crew member to override a captain's decision, even when that decision was about to kill 583 people. That accident did not just change aviation safety procedures. It triggered a complete reimagining of how the human mind operates inside a cockpit. A psychological engineering project so successful that its principles were eventually adopted by the military, by surgical teams, by nuclear power plants, and by offshore oil platforms. Industries that looked at what aviation had built and decided they needed it too. What was built and how it was built is one of the most important untold stories in the history of human safety.
Before 1977, the cockpit operated on a principle so deeply embedded in aviation culture that it was rarely stated out loud because it never needed to be. The captain is always right. Not as a policy, not as a written rule. As a psychological reality so thoroughly internalized by every crew member that challenging a captain's decision felt not just professionally risky, but fundamentally wrong. The industry called it cockpit authority gradient. The steeper the gradient, the more absolute the captain's authority, the more dangerous the cockpit. NASA researcher John Lauber conducted the first systematic study of cockpit crew dynamics in the late 1970s. His team placed observers on flights. They watched how crews communicated. They analyzed how decisions were made. They documented how errors were caught or not caught. What they found was systematic. Captains who maintained maximum authority gradient, who expected compliance rather than contribution, created crews that were operationally blind to the captain's errors. The first officer's job in that culture was not to be a second set of eyes. It was to execute the captain's decisions. And when the captain's decision was wrong, there was no functional mechanism to correct it before it became catastrophic. Lauber's research gave the problem a name: cockpit resource mismanagement. The name was later changed to something more constructive: crew resource management, CRM. And what followed was the most ambitious behavioral intervention in the history of professional aviation.
CRM was not a new checklist. It was not a new procedure. It was not a new piece of equipment. It was a deliberate reprogramming of the psychological environment inside the cockpit. The first CRM training program was developed by United Airlines in 1981, following direct collaboration with NASA's research team. It addressed something that no aviation training had ever formally addressed before: the human relationship dynamics that determine whether a technically competent crew functions as a safe operating unit or as a collection of individuals whose interpersonal dynamics make them collectively less safe than any single member would be alone. The training covered 5 domains that NASA's research identified as the critical variables in crew performance. Situational awareness, the continuous mental model each crew member maintains of where the aircraft is, what it is doing, and what it is about to do. Communication, specifically the architecture of how information flows between crew members and how that architecture can be deliberately structured to maximize error detection. Decision-making under uncertainty, how crews evaluate incomplete information and commit to actions with irreversible consequences. Workload management, how tasks are allocated across crew members to prevent any individual from becoming the bottleneck through which all critical information must pass. And the most psychologically complex of the 5: leadership and authority, specifically how a captain maintains operational authority while simultaneously creating an environment in which every crew member feels not just permitted but professionally obligated to challenge a decision they believe is dangerous. That last element, the psychology of constructive challenge, required solving a problem that no training program had ever formally attempted. How do you train a person to speak truth to authority in real time, under pressure, to someone whose approval controls their career, and do it in a way that actually works?
The solution CRM developed was counterintuitive. The problem with direct challenges to a captain's authority was not that crew members lacked information or courage. It was that direct challenge triggered a defensive response in the person being challenged, a response that made the challenged captain less likely to reconsider, not more likely, because the challenge felt like an attack on competence rather than a contribution to safety. CRM researchers developed a specific verbal protocol for crew members to use when they identified a concern. State the observation, state the implication, propose a solution, confirm understanding. Not, "Captain, you're wrong." Instead, "I'm showing us at 300 feet below the approach path. We may be low on glide slope. Should we execute a go-around?" The psychological architecture of that second formulation is precisely engineered. The crew member has stated a factual observation that cannot be disputed, connected it to a safety implication without attributing error, proposed a specific action, transferred decision authority back to the captain while making the correct action the natural response. This is not soft communication. This is a precision instrument designed by behavioral psychologists to penetrate the cognitive defenses of an authority figure under operational pressure and deliver safety-critical information in the format most likely to produce the correct response. The protocol was taught, then practiced, then evaluated, then practiced again, until it became automatic. Airlines began mandatory CRM training in the 1980s. By 1990, the FAA mandated it for all Part 121 air carriers. The results were measurable within years. The rate of crew coordination-related accidents, accidents where the crew had the information to prevent the outcome but failed to act on it effectively, declined by over 50% in the decade following mandatory CRM implementation.
CRM is now in its 7th generation of development. Each generation addressed a failure mode that the previous generation had not anticipated. Generation 1 addressed authority gradient. Generation 2 addressed the specific human factors in high workload environments, how attention narrows under stress, and how teams can compensate for individual cognitive limitations. Generation 3 incorporated threat and error management, the systematic identification of environmental threats and crew-generated errors before they develop into incidents. Generation 4 extended CRM beyond the cockpit, incorporating cabin crew, maintenance teams, and ground operations into a single integrated safety culture. Generation 5 addressed automation, specifically how the introduction of highly automated flight systems created new forms of crew coordination failure that the original CRM framework had not been designed for. Generation 6 focused on safety culture at the organizational level, recognizing that the psychological environment of a cockpit is shaped not just by training, but by the culture of the airline itself. And the 7th generation, currently being developed, addresses the introduction of AI systems into crew operations. How does a human crew member effectively challenge an AI co-pilot recommendation? How do the same psychological principles that enabled a first officer to constructively challenge a captain in 1981 apply when the authority being challenged is not human? The answer to that question is being worked on right now in research labs, in simulator studies, in regulatory working groups, because aviation already learned the hard lesson once, that the most dangerous thing in a high-performance system is not a technical failure. It is a team of technically competent people who cannot effectively communicate what they know to the person who needs to hear it most urgently. Aviation solved that problem once. It is solving it again. Follow for more about the hidden science behind the safest industry ever built by human beings.